In this video, we're going to look at slightly more difficult applications of the fundamental theorem of calculus. Given here, at t equals 0, an oil reservoir contains 10,000 liters of oil. To raise the level of oil, a pipe delivers 500 liters per hour into the reservoir. Find the time t such that the volume of oil in reservoir is 110,000 liters. We're going to apply the fundamental theorem of calculus. So what we have is integral of v prime of t dt from 0 to t, that's equal to v of t from 0 to t, that's equal to volume at time t minus volume at time 0. Let's rearrange this equation, and we get v of t is equal to v of 0 plus integral from 0 to t v prime of t dt. Let's interpret this. V of t is the final volume of oil in the reservoir. V of 0 is the initial amount of oil in the reservoir, and this integral is the integrating rate of change, and we get a total change in the volume of oil in the reservoir. All right, so what we have is v of t is equal to v of 0 plus 0 to t v prime of t dt. The final amount of oil in the reservoir is 110,000. The initial amount is 10,000 plus integral from 0 to t, and the rate at which the oil is flowing into the reservoir is 500 liters per hour. So we integrate the rate with respect to time. So what we have is, this is the final amount, the final volume. This is the initial volume, and this integral is the change in volume. Integrate rate of change, and you get the total change in volume. So what we get is 110,000. Let's subtract off the 10,000 is equal to integral from 0 to t 500 dt. 110,000 minus 10,000, that's 100,000. The 500 passes right through the integral because it's a constant, so we get 500. And integrating t dt, that's going to give us t squared over 2, reversing the power rule, and evaluate it from 0 to capital T. So we get 100,000 is equal to 250 t squared from 0 to t. Let's divide both sides by 250. Divide by 250. The left-hand side will be 400, and the 250 will cancel out, and we get t squared from 0 to t. So now we get 400 is equal to capital T squared minus 0 squared. That gives us t squared is 400. Square root both sides, and we get t is equal to plus or minus 20. Of course, we're only going to take positive time. T is equal to 20 hours. So it takes 20 hours to raise the volume of the oil in the reservoir to 110,000. We'll illustrate with a diagram. So it takes 20 hours to raise the volume of the reservoir from 10,000 liters to 110,000 liters. We start with 10,000 liters, that's the diagram on the left, and we add the rate of change, we integrate the rate of change, and that gives us a change in the volume of the oil, and that's the middle diagram. And when we add these two, we get a final amount, which is 110,000 liters of oil. So the big picture is at the bottom, 10,000 liters plus integral from 0 to 20, 500 t dt is equal to 110,000. All right, let's look at another application. Find the value of c such that the integral from 0 to c, 1 over 1 plus t squared dt is equal to pi over 4. We're going to apply the fundamental theorem of calculus. So what we have is integral from 0 to c, 1 over 1 plus t squared dt is equal to pi over 4. What is the antiderivative of 1 over 1 plus t squared? That's going to be tan minus 1t, because derivative of tan minus 1t is 1 over 1 plus t squared. Evaluated from 0 to c, that's equal to pi over 4. So tan minus 1, let's put the upper limit in, tan minus 1 of c minus tan minus 1 of 0 is equal to pi over 4. What is tan minus 1 of 0? Tan minus 1 of 0 is saying what is the angle whose tangent is 0? Clearly that is 0. Alright, so this is going to be 0. And what we get is tan minus 1 of c is equal to pi over 4. Now we need to solve for c, so let's take tangent of both sides. We get tangent of tan minus 1 of c is equal to tangent of pi over 4. Now it is clear that tangent and inverse tan are inverse functions, so we're going to get a cancellation. And we're left with c is equal to tangent of pi over 4. What is tangent of pi over 4? From the diagram, we can see that tangent of pi over 4 is opposite over adjacent. That's 1 over 1. So tangent of pi over 4 is 1. So the value of c is equal to 1. So let's interpret this in terms of an area. So what we have is integral from 0 to c. 1 over 1 plus t squared dt is pi over 4. That means find the value of c such that the area under the graph of 1 over 1 plus t squared gives us pi over 4. The value of c was found to be 1. That means if you integrate from 0 to 1, 1 over 1 plus t squared dt, we get pi over 4. All right, thanks.